All right, Freya, here we go. So, part A, find an expression for R in terms of H. And the height of the cone is 6, the radius is 4, and we've got the cylinder inside. Okay. So, what this boils down to is a case of similar triangles. So, in order to get this expression. So, let me just show you real quick. Okay, what I'm gonna do is like just if you think of the right side of the cone in 2 dimensions, if I just slice it right down the middle, okay, I have the height of 6 right here, and then the radius of the cone is 4. And I don't know, let's say the cylinder is here. Okay, and if I were to do it 3 dimensionally, then just to give you maybe a better picture, the cylinder is inside of the sphere or the cone, sorry, right there. But I'm going to do a straight line because we're doing a straight cut. Okay. So, and this cut is right here, right? So that means that from here to here is the radius of the cone. And so the side of the cone comes down here, which is the height, which means from here to here is also the height. Okay, so if you don't mind, I'm just going to erase this part. Okay, and if from here to here is the height, from here to here is going to be 6 minus h, because the entire height is 6. So if this part is h, then this part right here has to be 6 minus h. And what we have now are 2 similar triangles. And let me just draw them out. We got the little triangle here, up top here with R and 6 minus h. And then we have big triangle right here. Sorry for the horrible triangles. And this is 4 and this is 6. And since they are similar, I can write out this proportion. 6 minus h over 6 compared to 6 is equal to r over 4. And remember, we're trying to the goal is to find an expression for r in terms of h. So we need r equals something. So we're going to solve for r. So 6r is equal to 24 minus 4h. And divide by 6, and r equals 12 minus 2/3 h. So that is our expression for r. Okay. So for part B, we have to show that the volume is this guy. And what I found out when taking a closer look, and this was, I guess, part of my confusion, the book has this wrong. The volume is actually minus, instead of 24h squared, it's 12h squared. And I checked, and double checked, so I'm confident that it's supposed to be 12, so that must have been a typo. Okay, so we know that the volume of a cylinder is the area of the base times the height. So the volume is equal to, since the base of a cylinder is a circle, pi r squared h. And the whole reason we got an equation with r in terms of h is so we could substitute it in here. And the reason we wanted to do that, and this is just like IB to lead you through the problem, is if we're going to find the maximum or a minimum, and in this case it's a maximum, we're going to have to take a derivative, and we can only have one variable to do that. So that's why we need to change this r so it's in terms of h. So here we go. Pi times 12 minus 2/3 h. It's not 12. You saw that right away. It's 4. because if I divide by 6, which I'm sure you saw, 24 divided by 6 is 4. Glad I caught that. Okay, so pi times 4 minus 2/3 h squared times the height. Okay, so that I need to FOIL this, and I know you know how to FOIL, so I'm just going to cut right to the chase here, and I'm just going to rewrite pi times this thing times a. I'm gonna move the h over here, pi h. Okay, and if you FOIL this, you get 16 minus 16/3 h plus 4/9 h squared. Okay, so now I'm going to look back here, and I see that that my goal is 4 pi over 9, 36h minus 12h squared plus h cubed. So I'm just going to distribute the h through, not the pi, just the h, because pi is on the outside here. It's not in here. So I'm just going to leave it outside for now, and all the h's are inside. So I'm going to distribute this h through. So that's pi times 16h minus 16/3 h squared plus 4/9 h cubed. And this is kind of the hard part, especially if you don't like fractions. Okay. We have to get to 4 pi over 9 here. Well, I have the pi. That means I have to factor out 4/9 to get 4 pi over 9, which is fine for this guy, but it's a bit problematic for the rest of the terms. Okay, so I'm going to factor out the 4/9. So that's 4 over 9 pi. So what the heck happens here? Well, what really is happening is if I factor out 4/9, that means 4/9 times some number, I'll just say x, has to end up being 16, or whatever the coefficient is. So it turns out that this value, which is going to be the coefficient of the h here, would be 16 times 9 over 4. In other words, if you factor out a fraction, whatever is left is the coefficient, like the 16 in this case, times the reciprocal of the fraction. Okay, and that's always the case when you factor out a fraction. To see what's left, you multiply by the reciprocal. Well, 9 over 4, this went crazy. Okay, 9 over 4 times 16 is indeed equal to 36. So that's 36h. 9 over 4 times negative 16 over 3 is 12. And of course, we factored out a 4/9. So you could still multiply it by 9 over 4 because that's equal to 1 plus h cubed. And so that is our formula for the volume. 4 pi over 9, 4/9 pi, same thing. 36h minus 12h squared plus h cubed. Phew! All right, so now we have to find the first derivative and the second derivative. Okay, so for C, v prime is equal to, I'm going to leave 4/9 pi there. I'll write it as 4 pi over 9 now. Remember, it's the coefficient, so it's just waiting to see what happens to it. And then this derivative is what? 36 minus 24h plus 3h squared. Okay, and so the second derivative is the derivative of the first derivative. The 4 pi over 9 stays. It's really insignificant at this point. 4 pi over 9. And then the derivative of this guy inside is negative 24 plus 6h. Okay, so we've got that, right? And so now it says find the radius and height of the cylinder with maximum volume. Use the second derivative to justify your answer. Okay, so first derivative, we have to first find the critical points using the first derivative. So we're going to set the first derivative equal to 0. So 4 pi over 9 times 36 minus 24h plus 3h squared equal to 0. If I divide both sides by 4 pi over 9, I'm just left with this guy, which I'm going to rewrite as 3h squared minus 24h plus 36 equal to 0. Divide everything by 3, I get h squared minus 8h plus 12 equals 0. And if I factor that, it's h minus 6 times h minus 2 equals 0. So the height could be equal to 6, or the height could be equal to 2. So which one is it? Well, remember, this is the height of the cylinder. And the height of the cone is 6. So you can't have a cylinder because if the height is 6, there's no dimension to the cylinder. So it's impossible with these parameters for the height to be 6. So that means that the height is 2. Okay, and again, we're looking for the radius and height when it's a maximum volume, right? So we're pretty sure the height is 2. So we can actually find the maximum height or the value of h that maximizes the volume, I should say. Again, the value of h that maximizes the volume. We took the derivative of the volume, so we're finding the max or the min, but in this case, the max volume of the cylinder. Okay, so if h is, if the value of h is 2, then we should be able to find that this is a maximum. So we'll do the first derivative test, and I'm going to plug in a value between 0 and 2. And I could normally, in just a regular function, I could use negative values if I wanted, but it's impossible for the height to be 0. And I would choose 1 anyway. So if I plug 1 into the first derivative, I would get 4 pi over 9 is positive, so that's insignificant to finding the sign, S-I-G-N. 36 minus 24 is 12, plus 3 times 1, plus 3 is 50. That's positive. That's positive. Okay, so if I put in 3 for h for the first derivative, that would be what? 36 minus what? 72 plus, clearly that is negative. And this is good news because that means to the left of 2, the volume is increasing, and to the right of 2, it's decreasing. That means that is our maximum. Okay, and that is good enough to prove that the maximum occurs when the height is 2. However, these wonderful people say to use the second derivative to justify our answer. Okay, so this really is unnecessary for this problem, but I just wanted to show it to you so you know that you can get a max or a min using the first derivative. Okay, but to justify it using the second derivative, we're going to have to find the second derivative critical point by setting the second derivative equal to 0. The 4 pi over 9, if we divide, we get by 4 pi over 9, we get negative 24 plus 6n equals 0. Solving for n, we get n equals what? 4. Okay, so now we'll do the second derivative test. Or this isn't n, this is h, isn't it? Sorry about that, my bad handwriting. H equal to 4, so second derivative. Doop, boop. Let me redo that. Second derivative test. Critical point is 4. We do a test. If I plug in 3, negative 24 plus 18 is negative. This is a positive. Negative times a positive is a negative. Plug in 5, negative 24 plus 30 is positive. Okay. So that means that to the left of 4, the volume function is concave down. And we talked about this a little bit. I'm going to give myself a little bit more room here. Concave down. So that means the graph opens downward, and here, concave up, the graph opens upwards. So what does this mean? Well, if we have a maximum, the critical point of the first derivative has to occur on an interval where the function is concave down, because that's the only way you can get a maximum is when it's concave down, because a maximum occurs up here. You can't have a maximum when it's concave up, because like to the left here, it's going to keep going up and up and up and up. This couldn't be your maximum, okay? So that is the reason. How would you articulate that? Well, the critical point. Oh, I got to sneeze. Sorry. Oh. I'm sorry. The first, you could say something, there's a lot of different ways to say it, but the critical point for v prime at h equals 2 occurs where v double prime, let's see, I guess we should say v double prime is negative so v, meaning the original function and the graph of v, is concave down. And that's enough. I mean, that's a lot of words. And you could probably do it. We can talk about it when we get back together, but you could probably do it with symbols a lot quicker. Okay, so that's justifying it. I forgot to find the radius and the height. Okay, the height is equal to 2, and we already have ourselves a nice little formula for the radius right here, which is 4 minus 2/3 h. So we'll just plug that in. R is equal to 4 minus 2/3 the height, which is 2. So that's equal to 4, what? Minus 4/3. And 4 minus 4/3, if you want to do it in your head, maybe 1 1/3. Actually, I'd rather make 4 have a denominator of 3, so that's 12 over 3 minus 4 over 3. So the radius would be 8/3. That has to be less than 4 since the max radius is 4, and 8 over 3 is what? 2 2/3. So there you go. All right, hope that helped, and we'll see you soon.